Hi to all. Welcome to Srinivasphysicsclasses. Till now, if you not subscribe my channel, subscribe my channel and share to your friends. Comment. Today topic is magnetic induction at the center of current carrying arc. This is also Biot savart law application. Previously, we discussed about the one thing, that is, this is a current carrying loop, right? At the center of the current carrying loop, we find out the magnetic induction that we got as nu naught I by 2R. This we derived based on Biot savart law. Okay, then here this is the current carrying arc. Look at here, this is the current carrying arc. Arc is a part of circle, right? Arc is a part of circle. If you can take like this is a arc, and this is a current carrying arc, and due to that I want the magnetic induction at the center. The radius of this arc, which is a part of circle, right, is capital R. Okay, theta is this arc, current carrying arc, making some angle at the center, that is theta, right? Theta is angle made by the arc at the center of the circle. Capital R is the radius of the circle. I is the current in the arc. Then our question is that we want to find out the magnetic induction at the center, but to find out the magnetic induction we have to use the Biot savart law. This is also application of Biot savart law. While applying the Biot savart law, this is a current carrying wire, right? And on this small element we have to take its length is dl, and due to that magnetic induction is dB, right? dB, small magnetic induction dB. Its formula already you know, according to Biot savart law, that is nu naught by 4 pi into I dl sin theta by r square. To find out the magnetic induction, right, at this point, then we have to take the small element dl on the arc. From that, at a distance small r, I want to find out the magnetic induction, but this is small r in figure equal to radius capital R. Okay, and theta is angle between the small r and dl. Look at here, this is the dl. dl is in straight, r is the radius, r and dl are perpendicular. Theta is 90 degree we take. And one more thing, radius of the circle, that is we are taking as capital R. These two we should substitute in above equation, then we will get the magnetic induction as, this is Biot savart law formula, right? Nu naught by 4 pi into I dl sin theta is what? Sin 90. Sin 90 value is 1 by capital R square we will get, right? And this we will get like this, nu naught by 4 pi into I dl sin 90 is 1 by capital R square. Okay, this is the magnetic induction due to small element only, that means due to small part, but I want the magnetic induction due to total arc. Then when you know the magnetic induction due to small part as dB, then due to total arc means just we have to integrate. This is a small magnetic induction. If you integrate, then you will get the total. Okay, right. How you will get the total? Let us see the total magnetic induction. Total magnetic induction. Total magnetic induction we will get as B, right? Then how you will get that B? That B is equal to, we have integration dB, right? Then dB is already you know that we substituted here, nu naught by 4 pi into, right, here we got I dl by, this is capital R square, right? And this constants we have to write outside. Then in this mu naught I by 4 pi R square is a constant, mu naught I by 4 pi R square is a constant, integration dl will be there, right? What is integration dl? What is integration dl? But integration dl is, right, integration dl is what? Small element length. Integration dl is the total length of the arc. We will take it as L. Then how you will get the total length of the arc? We have one formula in the mathematics, that is if we have one formula in the mathematics, that is If the arc is makes an angle theta at the center, then how to find out the relation between the length of arc, radius and angle? Look at here, this is an arc. It is carrying I current and this arc length is L. This makes an angle theta at the center. Okay? And its radius is capital R or the small r, whatever it may be. Okay? Then we have one formula in the mathematics, that is angle is equal length of arc length is L by radius. This is the formula. From this, L is the length of the arc, dl is the small element on the arc, this is the arc. Okay? And integration dl is the integration is instead of summation we will use the integration. Integration dl gives the total length. Total length of the arc is equal, we write from here, r into theta. This we substitute in above equation, then we will get b is equal to nu naught I by, right, what you will get, 4 pi r square into integration dl is r theta, we write. This r and square will cancel. Okay, then we will get one formula for the magnetic induction, that is nu naught I by 4 pi r into theta. This is the formula for the magnetic induction at the center of arc. Okay, right. Now let us see. In this, what is theta? Theta is angle made by the arc at the center of the circle. Now this theta, the condition is there, one condition. Okay, the theta must be, okay, while using above formula, theta must be in radians. Theta must be in radians. Do you know angle measured in degrees? How to convert the degrees into radians? Right? In order to, we know that 180 degree is equal to pi radians. Okay? This we can use. Or the 2 pi 360 degrees is equal to 2 pi radians. This is in radians. Right? This we have to use in order to convert degrees into radians. This is the formula to find out the magnetic induction due to arc, okay, at the center of the arc. Now let us go for some application. This is the magnetic induction at the center of the arc. Arc carrying the I current, I is the current, nu naught is the permeability, R is the radius, theta is the angle made by the arc at the center. Now let us go for some application, some questions based on this. Okay, I will rub it and take the screenshot, note every point. Okay, these are the two questions based on the previous formula. Just now we derived one formula, magnetic induction at the center of the arc. That formula we have to use to solve these two problems. What they are and what is this? Find the magnetic induction at the center of semicircular current carrying wire as shown in figure. This is a semicircular current carrying wire. We have its radius is capital R and it carries high current. Then we have to find out the magnetic induction at the center. For that we have to join these points at the ends, and this point also we have to join to the center. On both ends of the wires should be joined to the center. Then this will be make some angle at the center, that is theta. Here the theta is 180 degree, right? Then here current they gave a solution, I am going to explain, right? The current is I, the radius is capital R, right? And then magnetic induction at the center, angle they gave is 180 degree. Okay, in our problem what we have like this, if a current carrying wire is there, if both ends are joined with the center, right, it is a arc like this there, it makes some angle theta at the center. Then the B formula at the center is nu naught I by S 4 pi R into theta. This is the formula, already we know, right? And this formula we have to apply it here, but here the arc is in the semicircle shape, right? Both ends are joined to center, it is making 180 degree. 180 degree is nothing but pi radians. Question, magnetic induction at the center they are asking. The formula for the magnetic induction is nu naught I by 4 pi R into theta. But what is theta at here? Nu naught I by 4 pi r into theta is 180 degree or pi radians. Here we write pi. This pi will cancel, then we will get the magnetic induction at the center of semicircular arc is nu naught I by 4 pi r, right? Like this we have to solve. Okay, and next let us go for one more problem, that is find the magnetic induction. Find the magnetic induction at a point, okay, that is P. In question P should be, P is missing, at a point P, right, at a point P in the following figure, right? In this figure at point P we have to find out the magnetic induction. The figure is quarter of circle, quadrant of circle. Dekhi, this is the 1/4 of circle, right? This circle 1/4 of circle, current carrying wire is in the shape that is arc, okay, and this arc is equal to, arc length is equal to 1/4 of circumference of circle. This arc both ends should be joined to the center of the circle, right? This is making some angle at here, that angle is here from the figure, it is 90 degree. Then question magnetic induction we have to find out. The current is I in this also, right? And the radius is again capital R in the question. They give angle made by the arc, current carrying wire, at the center is 90 degree. 90 degree converted into radians, right? 90 degree is equal to pi by 2 radians. 180 degree is the pi radians, means 90 degree is pi by 2 radian. Then magnetic induction we have to find out. The formula for the magnetic induction is nu naught I by, right, 4 pi r into theta. Yes, then the B we will get as nu naught I by 4 pi r into theta is pi by 2. This will cancel. Then we will get as nu naught I by 8 r, right? And this is the magnetic induction at the center, right? This is the magnetic induction. Okay, like this we have to solve the problems. Now let us go for some more point, and one more question I will explain. Okay, let us go for the question number 3 and question number 4. Okay, you take the screenshot and note the problems. I will rub and I will start the next questions. Okay, let us continue these problems, right? These two problems are important, and this is the previous CBSE problem, question number 3. Previously 2 problems we solved. Now next 3-4 problems I am going to solve, third and fourth problem. And the third problem is that to find the magnetic induction at a point P in the following figure. In this figure I want to find out the magnetic induction at point P. How to find out the magnetic induction at point P in this figure? What happening in this figure? There are 2 concentric circular loops are there. How they are? One is vertically like this there. Look at here, like this. Other is, one is vertically like this there, and other is horizontally is there, plane. That means the planes are perpendicular to each other. One is horizontal and other one is vertical. And now they are concentric, means their centers are coincide. They have the same radius. Look at here, the radius of this loop is capital R and the radius of this one also capital R. But they are carrying the different currents. First one is vertical, one is carrying I1 current, horizontal one is carrying I2 current. They are asking to find out the magnetic induction at point P, means at the center, common center, right? There are 2 perpendicular circular current carrying loops, 2 concentric circular current carrying loops. Their planes are perpendicular to each other. They are carrying currents I1 and I2, right? Then we have to find out the magnetic induction at the center. It was very simple, and listen very carefully. Then what one is like this there, right? According to right hand rule, current is like this there. Then what about the magnetic induction direction? Current is like this there. That means magnetic induction is right side is there. Curled fingers indicates the current and thumb indicates the field. Field is right side, right? That means due to vertical current carrying loop, the field is right side. Due to vertical current carrying loop, the field is right side. Okay? Or it may be left side. Actually it is appearing like this. It is appearing like this, right? That's why left side it will be there. This is the point P. This is the B1. And next, due to the second current carrying loop, the second current carrying loop is horizontally there, right? Like this it is there horizontally, like this it is there. Then magnetic induction, either current carrying in anti-clockwise means upward will be there, clockwise means current is in clockwise means field is in downward direction. Current indicates the curled fingers, thumb indicates the field, right? Current anti-clockwise, then thumb downward. Now here the current is like this there, anti-clockwise direction, okay? Then the thumb shows downward, curled fingers indicates the current and thumb indicates the field. The field is downward due to the horizontal plane, okay? That is B2, okay? Then we have to find out the net field. One is like this there, field B1, and other one is like this there, that is field B2. Then the net field is in the middle according to parallelogram law. This is the net field, okay? Then I want the net field value, okay? For that, first we have to find out the B1 formula. What is B1? B1 is a circular loop, that one. Due to circular loop, what is the formula to find out the magnetic induction at the center? This is circular loop. At the center, B1 formula, right? Nu naught I1 by, okay, tell me, what is the formula? Nu naught I by 2R formula, but I1 by 2R, right? And due to horizontal one, magnetic induction is B2 is equal to nu naught I2 by 2R. I want the net magnetic induction, angle between them is 90 degrees, right? B1, B2 are making 90 degree with each other. The angle between them is 90 degree. Then what is the net magnetic induction? Yes, the net magnetic induction formula is under root of B1 square plus B2 square plus 2B1 B2 cos theta. Here we write the net magnetic induction as under root of B1 square plus B2 square. But here remaining will become 0 because cos 90 value is 0. Cos 90 value is 0. Okay? And this term totally it will become 0. We substitute the values. B1 is nu naught I1 by 2R whole square plus B2 value is nu naught I2 by 2R whole square plus this total is 0. This term is 0 because cos 90 is 0. Then I want to find out the net magnetic induction. The net magnetic induction we will get like this. We have to common something here. Nu naught by 2R whole square we can common. Nu naught by 2R whole square. If you common, here what remains? I1 square remains. Here what remains? I2 square will remains. Then final answer we will get is net magnetic induction is equal to nu naught by 2R under root of I1 square plus I2 square. This is the formula we are getting. Okay, this is the net magnetic induction. If they carry same current, then I1 is I, I2 is I. Then I plus I square plus I square, 2I square, root 2I we will get. Root 2 into nu naught I by 2R we will get. Next let us go for one more problem. It was very simple. That is similar to that one. In that they are asking the question, that is find the net magnetic induction at the center of the concentric circular current carrying loops. Okay, in the following figure. This is a figure. In this they are asking to find out the magnetic induction at the center. At the center they are asking to find out the magnetic induction. B is equal to what? Here the magnetic induction is there due to there are 3 loops are there in this. 3 concentric loops. Concentric means the centers of 3 loops are coincide. Okay. Right, how the loops are there? The planes of 3 loops are perpendicular to each other. Let us go for the solution. But all the loops are carrying the same current and all the loops having the same radius in this. But in the previous case there are 2 loops and they have the different currents. Magnetic induction due to first loop, due to second loop, different formulas are there. Here how to find out the magnetic induction, net magnetic induction. First loop is like this there. Okay, let us see how the loops are there. There are 3 loops are there. one is vertical, right? It will be like this there, okay, and it will be like this, it is there, right? Then current is going like this, the field is left side will be there, okay. One is vertical loop and other one is horizontal loop. Already we know, due to vertical loop, what is the field direction? Due to vertical loop, field is left side. Current, curled fingers indicates the current like this, vertically, vertical circle, curled fingers making the vertical circle, these 4 fingers, and field either left side or right side, right? And already we know from here, B1 is left side, and next B2, that is the field due to horizontal plane, right? And it is in clockwise direction, that is already we know, downward. B2 is downward. And what about the third one? Third one is like this there, due to this magnetic induction, like this there, right? Why? Like this. If the current is like this there, then the field will be like this there, right? Then field is inward here, current is clockwise, the field is inward. Then B3 is, we write as cross, okay. There are 3 fields, B1 left side, B2 downward, B3 inward. 3 perpendicular fields are there. One is along x-axis, other is along y-axis, other is along z-axis. Then we write B1 is equal to B2 is equal to B3 is equal to magnetic induction at the center, that is nu naught I by 2R we write. They are carrying the same current, that's why all are having the same field and all are having the same radius, right? This is the magnetic induction due to one circular loop. Then net magnetic induction I want, net magnetic induction, okay. One magnetic induction is along x-axis, that is negative x-axis, minus B1 I cap we take, and the other one is negative y-axis, minus B2 j cap we write. Another one is along negative z-axis, minus B3 k cap we write. If you want to find out the net magnetic induction magnitude, right, this is in vector form, and now magnetic induction we write as under root of B1 square plus B2 square plus B3 square. And now we substitute all values here. In this, one thing that B1, B2, B3 values are same. B1 also B1, and B2 also we write B1, and B3 also we write B1. B1 square plus B1 square plus B1 square, we will get as root 3 B1 square. Net magnetic induction we will get as root 3 B1. What is B1 at here? B1 is already you know, nu naught I by 2R, right? Okay, in this problem I will tell, in the third problem I will tell some more information extra. Direction of net field, direction of B net field ka direction in this problem, question number 3, that is question number 4 is completed. Question number 3, direction of the net magnetic induction I want. Net magnetic induction is along this, in the middle it will be there according to parallelogram law. If 2 vectors are represented by 2 sides, then the resultant is at the diagonal. Then the resultant is making some angle alpha with x-axis, okay. Alpha is angle made by B net with B1, okay. Then what we write the tan alpha? Tan alpha is equal, we write as B2 by B1. Tan alpha equal, this is B2, this is B2, and this is B1. Then tan alpha equal, this is also B2, opposite sides are equal, okay. And this is B net. And now tan alpha equal to what we write? Opposite side B2, adjacent side B1. We substitute values. B2 by B1 you can find out, this by this, then we will get as nu naught by 2R will cancel, then we will get answer I2 by I1, okay. And these are the problems. I will give one homework problem, take the screenshot and note, and important problems. I will give one homework problem and then I will stop today lecture. Okay, look at here. This is our homework question, right? And you have to solve this problem yourself, right? Based on the today's concept or yesterday's concept, and give its answer in the comment. What is this question? I will read the question, right? Two identical loops P and Q. There are two identical loops. Look at here. This is the one loop and this is another loop. They are identical, means they have same radius, right? Each of radius 5 cm are lying in perpendicular planes. Their planes are perpendicular. One plane is like this there and other plane is like this there, right? Like this. The planes are perpendicular to each other, such that they have the common center, right? They have the common center. Find the magnitude and direction of the net magnetic induction and find the magnitude and direction of the net magnetic induction at the center of two coils. At the center of two coils, if they carry currents equal to 3 ampere and 4 ampere. Okay, in this gap nothing is there, okay? Nothing is there. And here they are carrying the currents 3 ampere and 4 amperes. We have to find out the net magnetic induction at the center. This model already problem we did in the concept. And the same thing is there, only here the values they give. They are asking to find the net magnetic induction. I think this is similar to the question number 3. We solved the 4 problems in that one problem, this one, right? And this is the magnetic induction due to one coil, left side or right side. Another coil upward will be there, right? They are perpendicular, upward or downward will be there. They are perpendicular to each other. Exactly similar to the third problem that we discussed today only. Okay, you can solve yourself and try it and compulsory do it. Write its answer in the comment. Thank you. We will meet in the next lecture.